Welcome everyone to Ask the Experts. I'm Tim Messagy, and today we're going to be talking about MIPI technology. And to do that, I am joined by my MIPI expert, Simone Bussières. Simone, welcome.
Hey Tim, hello everyone. So I'm happy to be here.
Great. Thanks for joining us, Simone. Simone, to start, give us some background on MIPI. What was the original application it was targeted for? What problem were they trying to solve?
So first, MIPI Alliance stands for Mobile Industry Processor Interface Alliance. Primary mission was, to develop interface specification to standardize communication between components in a mobile and, any mobile influence device. At the time of its creation, the mobile industry was rapidly growing, but it lacked a standardized interface for connecting components like the camera, the display, the processor, the modem. So each manufacturer often propose and use their proprietary solution, which come with some problem, increased development costs because everyone is developing its own solution, longer time to market, obviously compatibility issues because one vendor has to pick a specific proprietary standard, and of course limited scalability and innovation because it's all close to a specific company, so there's no exchange of information and collaboration. But MIPI Alliance aimed to solve this problem by creating an open standardized interface, set of specification to enable interoperability between components for different vendors, to reduce the design complexity, lower the power consumption by selecting the best feature of every specification, improve performance and scalability, obviously. So MIPI has developed over 50 specifications. Some of the most widely adopted include MIPI CSI2, the camera serial interface that is used for connecting cameras and sensor to processor. Another protocol called MIPI DSI2. This one is to connect displays to the application processor. On the physical layer, two main specifications are MIPI C-PHY and D-PHY. Physical layer specification for high-speed data transmission between components. There is also the MIPI I2C specification for component control interface. And finally, MIPI RFE for analog front-end component control.
Simone, you mentioned 50 different protocols. Are they all for mobile? How has MIPI evolved since that initial focus on mobile phones?
That's a good question. MIPI started in the mobile space, but its specifications are also widely used in automotive system nowadays, like for ADAS and system, self-driving cars, into the infotainment system of a car, but also IoT devices, wearables like watches, AR, VR headset, now also industrial and medical equipment. The good thing is companies from all these industries are actively participating in the MIPI work groups that develop the standards. So they are all collaborating to come up with specification that suit the needs for all those industries.
Simone, specifically around ADAS that you mentioned, I know cameras and sensors are a big part of autonomous driving and ADAS. Please go into some more details on MIPI's role in the automotive market.
Yeah, in fact, automotive industry is now leveraging the mobile smartphone technology. For instance, MIPI CSI2 is widely used to connect cameras and sensor like radar and lidar to the automotive ECU. So during the last years, MIPI had a strong focus to add automotive grade enhancement on top of the base protocol and physical interface specification because ADAS and automotive system must meet ISO 26262 safety standards, but also be resilient to cyber threat. So MIPI has introduced its automotive SerDes solution called MAS to support long-reach connectivity up to 15 meters. It's a new automotive-grade physical layer, a PHY that is specified under the name of A-PHY. It's now at version 2.0. Also, MIPI added the functional safety specification with end-to-end protection approach. So that faulty component in a car affecting critical operations such as self-driving can be easily detected. A completely new security framework that includes end-to-end protection from sensor to the ADAS SOIC is also specified now by MIPI. It includes authentication, data integrity, and encryption capability to protect the sensor data stream, through the whole network in the car. So the new two key specification that were released are MIPI CSE, the MIPI camera service extension. It's on top of the CSI2, base protocol. The CSC will specify the hardware mechanisms that are needed to support end-to-end protection. By protection, I mean both the security and the functional safety. The second specification is the MIPI security that defines the software level security handling, the security profiles for the MIPI camera security framework. At the end, it's to enable interoperability between components, including also the profiling of the various security variants that are supported. And it's based also for authentication on the widely deployed SPDM mechanisms that other industry are already leveraging. So as you can see, MIPI is committed to continue enhancing the specification to meet stringent requirements of the automotive industry.
So it's really a very broad landscape of electronic systems and technical challenges that you've described. What does Rambus offer for chip makers who want to incorporate MIPI technology in their chips?
Yeah, so Rambus offers a comprehensive suite of MIPI IP solution tailored for chip design in any application like mobile, automotive, and any embedded system, in fact. So we offer fully compliant CSI2 and DSI2 controllers as soft IP cores to be integrated into ASIC or FPGA design. They are the most versatile controllers on the market. We continuously update this IP core to support the latest CSI2 and DSI2 specification version that comes out from MIPI. Any recent feature, we will add them to the controller. Each controller is parameterizable and scalable and can be tailored to the design needs. For instance, we can change the internal data path width, operate at 32-bit, 64-bit, or 128-bit, so that the performance required essentially to match the link bandwidth can be achieved in any target process node. The number of supported D-PHY and C-PHY trios can be selected, obviously. There are various options to ease the integration with the design logic, depending on the type of video or camera or sensor stream. The interface with the core can be adapted to support, video live stream with fixed timing, or at the opposite, more bursty raw data exchange. So both extreme are supported with many options in between. The cores we offer can be integrated with CD5 from any IP vendor or any customer own design, own in-house PHY also could be used with our controller. So they are agnostic to the PHY, in fact. So we have also close partner that can provide high quality PHYs, and we collaborate with them to offer seamless integrated PHY and controller solution to our customer. So the customer doesn't have to worry about the integration. It's going to receive controller and file integrated and verified properly. For automotive safety critical application, the controller are also offered in automotive ready variants as per ISO 26262 ASIL B process and soon ASIL D process too. Customer can request IP configuration specific safety deliverable. Standard safety manual, FMEDA, and DFMEA. Also, to better address automotive market demands, we're developing new MIPI controller solution that will be based on the new MIPI security framework. So fortunately, Rambus is a world leader security solution provider. So it greatly facilitates the integration of major security technology into the MIPI controller. So we can provide the same reliability as before, but include a new component, the security core. And not to be forgotten, we are also working on supporting seamless integration with long-reach PHY for automotive, such as MIPI FI and ASA Motion Link from the Automotive SerDes Alliance. Finally, we also offer VISA DSC, Display Stream Compression IP cores that can be used along with the DSI2 controller cores. They can be used to reduce the bandwidth required on mobile, AR, VR, and vehicle display interface.
So broad portfolio of solutions, lots of configuration options and application-specific certifications and features. Are there any other reasons that chip makers should choose Rambus?
To that question, Tim, I simply normally answer because we have the best controllers. But let me develop further on this. Our IP core offer very high performance. They are low gate count, low power. They are easy to use core also. Like I explained, there's a lot of option for interfacing with the design logic. The cores are fully CSI2 and DSI2 specification compliant. So there's no concern to have about that. Just to remember, the first version of the MIPI IP core were developed in 2010. So since then we constantly enhance this core with new features, optimizing them to offer the best solution. In terms of supporting customer in various industry, we've seen a lot of different designs, so we can provide good guidance to the customer in terms of how to integrate the core. We offer both the receiver and the transmitter with the same features and options on both sides. As mentioned earlier, Rambus also collaborate with the leading CD5 supplier to ensure seamless integration. We also, when we deliver our solution, we also provide a test bench that allow the customer to simulate various operating mode of the controller, so that makes it easy to during the integration phase. We offer customization and integration services to customer. For ASIC design, we support integration on FPGA for prototyping, so we can deliver additional deliverable that will allow the customer to prototype on Xilinx or Altera device. We offer good technical support. We involve directly the design team. So this is normally really appreciated by our customer. Rambus MIPI controller are silicon proven in a wide variety of target process and used in over, let's say, hundreds, like more than 400 ASIC and FPGA design across the industries. So in a nutshell, we can provide a reliable MIPI solution that will contribute to the success of our customer. So can say I'm proud of it.
Thank you, Simone, for those insights. And thank you, everyone, for joining us. We'll see you again back here on Ask the Experts.